All right, the time has come for us to start factoring. Not just taking out that GCF we did last week, but now we're going to start factoring trinomials into binomials. Basically what we're going to do is, well, I'm not going to tell you yet. You're going to have to find out as we go. So this is kind of our little intro. So this first part is asking us to find the dimensions or factors given the area. So we're going to work backwards from the box. We know that when we multiplied, we started with a binomial up here, a binomial on the side, and then we multiplied them to get what went inside the box. Then we took the terms in the box and we pulled them out to get a new polynomial, which in this case, 3x squared, boom. Combine those to get 11x, and then we've got positive 6. So our goal on this is to go through and find what terms should be on the outside that allow us to multiply and get this area. So the first thing we're going to do is we're going to take out our greatest common factor. So we are using that. We're going to take out our greatest common factor from the top row. So if I look at 3x squared and 9x, I know that the greatest common factor for both of those terms is going to be 3 and x. Once you take out the common factor from that top row, the rest of it is just figuring out what do we need to multiply in order to get each of these boxes. So to get 3x squared, I know that's going to be 3x times x. To get 9x, I know that that's going to be 3x times a positive 3. And then to get 2x, that's going to be x times positive 2. And then finally, if we want to double check, we can make sure to get this, it should be positive 2 times positive 3, which does in fact multiply to 6. So we were able to work backwards to figure out that the dimensions or the factors that made this box were 3x plus 2 and x plus 3. Or, again, order of multiplication doesn't matter. You could also rewrite it with these in the opposite spots. So you could call it x plus 3 times 3x plus 2. As long as you keep the x plus 3 in one parentheses and 3x plus 2 in the other parentheses, the order doesn't matter. All right, same thing for this next one. We're going to take out the greatest common factor of this first row. So we're going to, for 5x squared and 10x, that's going to be 5x. And then I know to multiply to get 5x squared, that's going to be 5x times x. To get 10x, that's going to be 5x times positive 2. To get 6x, that's going to be x times positive 6. And then I can double check to get 12. That needs to be 2 times 6, which works. So perfect. So my final dimensions or my factors are 5x plus 6 and x plus 2. So again, this isn't necessarily factoring yet. This is just part of the step of how we're going to get there. But if you can learn this process, it's going to help you when we start to actually factor. So same thing, find my common factor, which is 2x. To get 2x squared, that's going to be 2x times x. To get negative 10x, that's 2x times negative 5. And to get positive 5x, that's going to be 1x times positive 5. And then I can double check, negative 25 needs to be these two terms here, which negative 5 times positive 5 does make negative 25. So 2x plus 5 times x minus 5. And then finally, this last example, if I take out my common factor, that's going to be 7x. To get 7x squared, I need 7x times 1x. To get negative 14x, I need 7x times negative 2. And to get the negative 2x, I need to do 1x times negative 2. And I can double check. My last box should be this term times that term. And negative 2 times negative 2 is positive 4. So we end up with 7x minus 2 times x minus 2. What I want to do right now, though, is I'm actually going to erase all this. And I want to see if we can notice some patterns that are going to allow us to start solving these problems if nothing is in the box. If all we give you is the area, and we're going to try to figure out what goes in here so that we can then figure out what the factors were. So give me a second here. In the meantime, I hope you're having a great day. Hope things are going well. Hope you're learning how to do all this math. I don't know, it might even be easier, right? You can go back and rewind things, pause it, you know, call your friend, do a little FaceTime, something. I don't know. Anyway, all right, so I want to look for some patterns. And I want to look at the area, and then I want to look at what's in the box. And so as I start looking at these patterns, the first thing that I notice is 3x squared, 3x squared. That top left box, 5x squared, 5x squared. 2x squared, 2x squared, 7x squared, 7x squared. So the first thing I notice is that the first term, which later we're going to call that our a value, our leading term. It's the 2 is actually your a value, but this whole term right here that has your a, the 2x squared, that first term goes in top left box. Or I usually say first term, first box. I consider that the first box. Okay, as I looked at these, and normally I'd have you guys like sit down for 5 minutes and try to find these patterns. So if you want to pause it and look for more patterns, like go for it. But since you're not here, I'm just going to keep going. The next thing that I noticed is my last term, which we're going to later call our C value. That last term is always in the last box. So 12, 12. Negative 25, negative 25. If I know the area, or if I know this is called a quadratic or a trinomial, I know that that last term is going to go in that last box. Okay, so that was the second pattern, or the second thing I noticed emerging. So last term goes in the bottom right box. Or again, I say first term, first box, last term, last box. You might be thinking, what in the world is he even teaching me right now? I have no idea how this makes sense, and it's okay. You might feel that way right now, but I promise eventually it's all going to start to come together and you'll understand why I'm teaching you this right now. The next patterns are a little bit trickier. Usually if we have enough time in class, you guys figure these out, and it's kind of cool when the light bulb goes off and you're like, oh, I noticed this. But the next pattern that emerges is if we take the two boxes that are left over, the two where our x's usually end up, if you add those together, 2x plus 9x, they add to the middle. Let's see if that works here. 6x plus 10x, boom, 16x. Negative 10x plus 5x, negative 5x. That is what they add up to. And then this last one, negative 14x plus a negative 2x is negative 16x. So 3 is, I'm going to call those the two open boxes, because at this point we only had the first term and the last term, so these were kind of our two leftover. Maybe we'll call them the two leftover boxes. Sure, why not? So the two leftover boxes must add to the middle term, which is actually going to be called our B later on. So A, B, C, right? A, B, C, pretty easy, alphabetical. But anyway, the two leftover boxes must add to the middle term. So the two leftover boxes must add to the middle. All right, there's one more pattern, and this one is definitely the hardest one for most students to find. But if I multiply this diagonal, 9x times 2x, I get 18x squared. If I multiply the other diagonal, 3x squared times 6, that is also 18x squared. That's interesting. I wonder if that'll happen again. 6x times 10x is 60x squared. 5x squared times 12 is also 60x squared. It happens every time. Negative 10x times 5x is negative 50x squared. And then if we check our other diagonal, 2x squared times negative 25 is also negative 50x squared. And then as you can imagine, this one will work as well. We get 28x squared. And then if we multiply this diagonal, that is also 28x squared. So we've got 4 patterns that we've hopefully been able to recognize. So again, that fourth one, sorry for my sloppy handwriting here. The 2 diagonals multiply to the same product. That just means if you multiply the diagonals, both of them are going to give you the same answer. All right, so how is this going to help us out? Well, our goal is that we're going to start taking pieces of the box away. And we still want you to be able to figure out what are the factors that go on the outside, or what are our 2 binomials that are getting multiplied together. So it's called factoring because we're trying to figure out what were the original factors that multiplied to give us this area. So I know first term, first box, last term, last box. But then what did I know about these 2 unknown boxes, or the leftover boxes? Well, we remembered that the 2 leftover boxes must add to the middle. So if my middle term is 10x, I know that 6x has to add with 4x in order to get my 10x. Then I can double check, do the 2 diagonals multiply to the same product. 6x times 4x is 24x squared. 3x squared times 8 is also 24x squared. So all 4 of our patterns, boom, 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 they all work. So then finally we can find what our dimensions are, or our factors. Again, the way I like to do it is I take out the greatest common factor from the first row, which is 3x, and then I find what goes around the outside. You could also take out the common factor of any row or column, it doesn't matter. Like if I take this one, 4x and 8, the greatest common factor is 4. Same thing if I do it here, the greatest common factor vertically is x, and the greatest common factor vertically here is 2. And that'll actually give me the answer as well, because if I double check it, 3x times x is 3x squared, 3x times 2 is 6x, 4 times x is 4x, and then 4 times 2 is 8. So you could do it by taking the GCF out of both rows and both columns. Or again, the way I usually do it, I take out my GCF of the top row, and then I just figure out, in order to get 3x squared, that would be 3x times x. In order to get 6x, that would be 3x times a positive 2. And in order to get 4x, that would be x times a positive 4. And I can double check, 4 times 2 needs to give me this box, which it does. So my dimensions, or my factors, are 3x plus 4 and x plus 2. All right, here's another one where we took away a box. Again, first term, first box, yep. Last term, last box, yep. We need to add to 1x though. So my leftover boxes, in order to add to 1x, I need a negative 5 to combine with a positive 6. Because 6x minus 5x is 1x. My diagonals both multiply to negative 30x squared, so that's good. And now I can go through, take out my common factor from my top row. 5 and 6 don't have a common factor, but they both have x's, so I can take out x. To get 5x squared, this has to be 5x. To get 6x, I need plus 6. And to get negative 5x, I need 5x times negative 1. Double check, negative 1 times 6 is negative 6. Beautiful. And we are on a roll. We are starting to factor. 5x plus 6 times x minus 1. I was going to skip these, but I'm not going to. I'll just go a little quicker. So the more we can see it, probably the better. And you can't fast forward, so you got to watch. All right, so first term, first box, last term, last box. These leftovers need to add to 12. So 14 and -2. Once I have that, I can start finding my dimensions or the factors by taking out my greatest common factor from the first row, which will be 7x. To get 7x squared, I need 7x times x. To get 14x, I need 7x times 2. Notice I don't put 2x, because if I did that, that would be 14x squared. I don't want that, I want 14x. And then finally, to get -2x, I need x times -2. And -2 times +2 is -4. So our dimensions, 7x minus 2 times x plus 2. One more of these. First term, first box. Last term, last box. The leftovers. Oops, I left off the x. Fixed it. We know that those need to add to -16x. So -1 and -15x are going to make that -16. And then we can take out our common factor from this top row, which the only common factor is the x that they both share. To get 5x squared, we need x times 5x. To get -1x, we need x times -1. And to get -15x, we need 5x times -3. And again, to double check, -3 times -1 is +3. That is beautiful. Which gives us x minus 3 times 5x minus 1. All right, so hopefully you're getting the hang of this. Let's ramp it up a little bit. So now we didn't give you either of the leftover boxes. We still know that first term, first box, last term, last box. But then I know that these leftovers need to add to 32. The problem is, I have an infinite number of ways to add to 32x. I could do 30x plus 2x. I could do 20x plus 12x. I could do 1000x plus a -968x. I could do -1,349,000. Okay, I think you get the point. There's a lot of ways that I can add to 32x. So how am I going to pick from all of those different ways which numbers are going to go in here? Right? That's kind of weird. Well, this goes back to that fourth pattern we noticed, which was that whatever these multiply to has to be the same thing that these multiply to. So if I multiply 3x squared times 20, I get 60x squared. So I know that my leftover boxes need to multiply to 60x squared. I also know that these leftover boxes always have to add to the middle. So they're going to add to 32x. So this is where you've got to start using your number sense, and you just sit there, and sometimes you'll find it right away. Sometimes you might be writing numbers down or thinking of numbers in your head for like 5 minutes until finally it clicks. Like, oh, those will work. So when I'm sitting here, I'm thinking I need to add the 32, multiply to 60. Well, how about 30 times 2? So I know that if I have 30x and 2x, if I add those together, they do add to the 32x, or the 32x I'm trying to get. And I also know that if I multiply them together, they multiply to 60x squared, which is good. So I'm going to take my two terms that I found, and I'm going to plug them into these empty boxes. Which one you plug in where doesn't matter. It's kind of nice. If I put the 2x here and you put the 2x there, we're still going to get the same answer in the end. But I'm going to put my 2x there, so my 30x would go here. And now that I've got all four terms in the box, I can factor out my GCF and do the same thing that we did on the front page. So common factor, x. To get 3x squared, this has to be 3x. To get 2x, we need plus 2. And to get 30x, we need positive 10. So in the end, my factors end up being x plus 10 and 3x plus 2. Woo! Now we're getting into the fun stuff. So here we go again. First term, first box. Last term, last box. These leftovers need to add to 17x. So I'm going to put a little note. Let's separate those two problems there. I need to add to 17x. Actually, you know what? I'm going to go ahead and erase this answer. We're done with that problem anyway. But I know that these two boxes have to add to the middle term. They have to add to 17x. I also know that this diagonal, which are my two empty boxes, have to multiply to the same thing as those two boxes. Which if I multiply those, that gives me 42x squared. So my task now is to find which two terms can add to 17x and multiply to 42x squared. All right, well, pro tip, don't think of all the things that add up to 17, because there's an infinite number of ways we can add to 17. Start with all the things that multiply to 42. So I might start with 1, all right, 1 times 42. Well, if I multiply those, I get 42, but if I add them, they would add to 43. That's not going to work. So then maybe I try 2. 2 goes into 42 21 times. Well, 2 plus 21 is 23. That's not what I'm trying to get. So then I go to 3. 3 goes into 42 14 times. So we know 3 times 14 is 42. But I also know that 3 plus 14 will give me the 17x. I found it! So I'm going to put 3 and 14 in my box, but I need to make sure that I put x's on them. So I really have 3x and 14x. Again, where I put them in the box doesn't matter. I can put the 3x either spot and then the 14x in the other spot. As long as you have 3x and 14x as those two missing terms, you're going to be good. And then we can take out our common factor, which for those two terms is just the x, because 7 and 3 don't have a common factor. To get 7x squared, I need this to be 7x. And to get 3x, I need to do x times 1. 3, my bad. And then to get 14x, we need 7x times positive 2. And we can check, 3 times 2 is 6. So we end up with x plus 2 times 7x plus 3. Okay. Bum, bum, bum. There is nothing in the box. We have gotten to the point where we are now going to start factoring when we are only given the trinomial, which this trinomial is a quadratic because the largest exponent is 2. So a little reminder on quadratics. You might remember from IM1, the graph of it will always be a U shape. We'll talk plenty more about quadratics though, so let me just keep factoring. All right, so what do I know? I know that the first term goes first box. I know the last term goes last box. And I know that my two unknowns, or my two leftovers, have to add to 9x. But they also have to multiply to the same product as this diagonal. So 2x squared times 9 is 18x squared. So my job is to now brainstorm and figure out what two terms will multiply to 18x squared, but add to 9x. So as I go through some different combinations, maybe I go 1 times 18, but that won't add to 9. 2 times 9, but that doesn't add to 9. 3 times 6, ooh, we might have a winner. 3 times 6 is 18. 3 plus 6 is 9. So this is really 3x and 6x, right? So I'm going to put 3x in one of my boxes, 6x in the other box. And now we can finish out by factoring our top row. The term that goes into both of those is just x. To get 2x squared, I need x times 2x. And to get 3x, I need x times a positive 3. And then to get 6x, that'll be 2x times a positive 3 as well. And then 9 would be 3 times 3. That works. And we end up with final factors or dimensions. Go ahead and toss it up over here. We get x plus 3 times 2x plus 3. Kind of becomes like a game or a puzzle. You're just finding what fits in the puzzle, and it's the same pattern every time. Nice thing is, once you get the hang of it, you can do all of them. It's the same thing every time. So again, first term, first box, so 3x squared. Last term, last box. These two leftover boxes have to add to 7x, but they have to multiply to the same product as this diagonal, which would be 6x squared. So we sit there for a while, we think through the different combinations, and finally I figure out, oh yeah, 6x and 1x, those will multiply to 6x squared, and they will add to 7x. So those are my leftover terms. Then we take out our common factor of the top row, which would be 3x, and then work our way around the box to figure out what else needs to go to make sure we get these terms. 3x squared is 3x times x, 6x is 3x times 2, 1x is x times 1, and then 1 times 2 equals 2. So we end up getting factors of 3x plus 1 times x plus 2. All right, we've got a couple more of these. First term, first box. Last term, last box. We need to add to a negative 8x. And we need to multiply to negative 84x squared. All right, we just upped the difficulty level. This one's got a lot of different combinations. Also, if I know that it multiplies to a negative number, what do I know about the two numbers? In order to multiply to a negative, I know I have to have one negative and one positive. So I have to find a negative and a positive that multiply to negative 84, but have a difference of negative 8. So let's see, 84. I'm going to use my calculator. That's going to help me. I know the two numbers are going to be 8 apart. So let's try, wow, lucky guess, first time, amazing. I tried 14, and I got 14 and 6, which 14 and 6, let me double check, 14 times 6 is 84. I need it to be a negative though, so I'm going to have to make one of these negative. But then they also have to add to a negative 8x. So if these are going to add to a negative 8, I know that my bigger number has to be the one that's negative. So negative 14 plus 6 is negative 8. Negative 14 times 6 is negative 84. And then to make sure we have the x's, they're both going to have an x. So my two terms that are going to fill in the box, negative 14x and positive 6x. Now when you run into a problem like this where the numbers are a little bit bigger, it's okay if it takes you 2 minutes, 3 minutes, 10 minutes to finally figure out what the two terms are. You're going to have to do a lot of guess and check. Use your calculator. Try a bunch of different combinations, but make sure you're not trying to find what adds to negative 8. You're starting with prioritizing what multiplies to negative 84 and then seeing if they add to negative 8. That'll be a lot more efficient. All right, so now that we got those terms, we can take out our common factor, which is going to be 7x, x, negative 2, positive 6. Multiply those together, you get negative 12. We've got a winner. We've got 7x plus 6 times x minus 2. Side note, a way to check your answer is multiply these back together. How do we multiply them back together? We use the box. So if we were to put these on top and on the side of a box and multiply them together, guess what we would get? You got it. We would get that as our polynomial. So factoring is really just the reverse of multiplication. All right, we'll just keep rolling. This is fun. I'm having a great time all by myself. You can probably tell I'm a little lonely, but it's all right. I'm going to keep going. All right. First term, first box. Last term, last box. They need to add the unknown, the leftovers, need to add to negative 29x, but they need to multiply to the same product as this diagonal, which is negative 30x squared. Because they multiply to a negative, I know that one number is positive, or one term is positive and the other term is negative. I also know that when I add them together, they're pretty far apart. So I'm not going to try two numbers that are close together. I'm going to try numbers that are far apart. And after you try a few, or maybe even on the first try, you get negative 30x and a positive 1x, which will multiply to negative 30x squared. But if you add them together, they do add to negative 29x. We're going to throw those in the box. We'll put negative 30x here, positive 1x there, and then I'm going to factor out my top row. My greatest common factor is 2x. To get 2x squared, I need an x. To get negative 30x, we need minus 15. To get 1x, I already have it, so I just need to multiply by 1. And then 1 times negative 15 is negative 15. And we are making factoring look easy. I got a secret for you. If you're understanding this right now, basically what we're going to do for the next 2 days or 3 days, you already know how to do. It's going to be nice. If you're not getting it yet, keep sticking with it. Keep trying. We'll be on Zoom. You're going to figure this out. All right, last two problems here. First term, first box. Last term, last box. I feel like we should make a dance routine to this or something. Extra credit. Make a dance to this. And then the leftovers need to add to 14x, but they need to multiply to the product of this diagonal, which 5x squared times 8 is 40x squared. So now I go through and I take some time, use my number sense, use my calculator, brainstorm. Two terms that multiply to 40, but add to 14. Since they multiply to a positive and add to a positive, I know it's going to be two positive numbers. And eventually I come up with 10x and 4x. 10x plus 4x is 14x. 10x times 4x is 40x squared. So I'm going to put those in my box. We're going to factor out my common factor from the top row, which is 5x. 5x times x is 5x squared. 5x times positive 2 gives me 10x. And x times positive 4 gives me 4x. Double check. 4 times 2 is 8. And we have found the two binomials that if we multiply them together will give us this area. All right, last problem for this lesson. Let's go same colors here. First term, first box. Last term, last box. The leftovers have to add to 13x. And then what do they multiply to? Multiply to the same as this diagonal. So 7x squared times negative 2 is a negative 14x squared. Again, using what I know about multiplication, if they multiplied to a negative, I know one term has to be negative, one term has to be positive. And if they're going to add to 13x, I know that they're pretty far apart. I also know that my bigger term is going to be positive since they added to a positive. And I end up getting a positive 14x and a negative 1x.